Hello guys, this is Shirup Doctor from Expert Mathematica. Today I will be discussing a question from CSIR NET December 2023. Question number 32 and question ID 704083. So this question is from linear algebra. And it is given question is 7 cross 7 order block diagonal complex matrix A has blocks 0, 1, 0, 1, 0, 0 and this block. So given its Jordan canonical form J of A, which is 7 cross 7 order matrix, is given that 0, 1, 0, 1, 0, 0, 2 pi I, 1, 0, 2 pi I and 2 pi I. 7 cross 7 and another portions are 0. This given, and you have to find its characteristic polynomial, and this question is from part C. Okay, this question is from part C, and question number is 4. And question has 4.75 marks, so you have to check its multiple options. Now for first block, its characteristic polynomial is x, its characteristic, and for second block its characteristic polynomial is x minus 1. And for third block, its characteristic polynomial is x square. Let me erase this. Its characteristic polynomial is x square, and for this block, its characteristic polynomial is x minus 2 pi I square. Since if we take that matrix P is 2 pi I, 1, 0, 2 pi I. If we take P minus 2 pi I into identity, it is not a zero matrix. But if we take P minus 2 pi I into identity square, we will get that zero matrix. So its characteristic polynomial is x minus 2 pi I square. And for this we have characteristic polynomial is x minus 2 pi I. So its total characteristic value, characteristic polynomial, is given as x into x minus 1 into x square into x minus 2 pi I square into x minus 2 pi I. If we combine all of this, we will get x cube into x minus 1 into x minus 2 pi I cube. So option 1 is correct. Now I have to check minimal polynomial. So to check its minimal polynomial, first we have to write this matrix again. G of A is given as 0, 1, 0, 1, 0, 0 and 2 pi I, 1, 0, 0, 2 pi I, 0, 0, 0, 2 pi I. Or you can write like previous one, anything you can. It has two Jordan blocks. And for first block, we have minimal polynomial, say m1x is x. For second Jordan block, we have minimal polynomial is x minus 1. And for third Jordan block, we have minimal polynomial m3x is x square. Since that matrix, say Q, is nilpotent matrix of order 2, so Q is not 0 but Q square is 0, so its minimal polynomial is x square. And for this Jordan block, same, m4x, its minimal polynomial is x minus 2 pi I square. Since that matrix P minus 2 pi I square is 0 but P minus 2 pi I is not 0, where P is 2 pi I, 1, 0, 2 pi I. So for this Jordan block, we have minimal polynomial x minus 2 pi I square, and for this block m5x, it has minimal polynomial x minus 2 pi I. So let me erase this. So what we have now, we have 5 minimal polynomials. Now m3x m3x is x square, and m1x is x, and we have m4x is x minus 2 pi I square, and m5x is x minus 2 pi I. Now what I am trying to say is m3x will help to annihilate that minimal polynomial x. Similarly m4x. So for minimal polynomial, if we take the minimal polynomial, we will take only that m3x and m4x. So we have total minimal polynomial of a is given as x square into x minus 1 into x minus 2 pi I square, and another things will be annihilated. So minimal polynomial is x square, okay, and x minus 1, okay, but x minus 2 pi I cube is given. So option 2 is incorrect. Now we have to check dimension for each eigenvalue 0, 1 and 2 pi I. Let me again write this. Sorry, let me remove this. I'll discuss all of this here. Thank you for being patient with me. So to find all of its eigenvalues, eigenvalue is given. Eigenvalue is 0, 1 and 2 pi I. Now we have to find eigenspace, dimension of eigenspace. Corresponding to this column, we will get one eigenvalue. Corresponding to that block, corresponding to that Jordan block, we will get one eigenvalue. Corresponding to one eigenvector corresponding to eigenvalue, eigenvector and eigenvalue. Corresponding to 0 eigenvalue, we will get one eigenvector, and corresponding to 1 eigenvalue, we will get another one eigenvector. Corresponding to this Jordan block, this Jordan block is given as, say, write Q. I have written previously. Q is written as 0, 1, 0, 0. Now it's a nilpotent matrix of order 2, so it is non-diagonalizable matrix. Non-diagonalizable. So corresponding to one eigenvalue 0, we will get one eigenvector. You can check very easily. One eigenvector will be checked, and if you try to find out that eigenvector, so apply that definition 0, 1, 0, 0 into v1, v2 will be 0. From this we will get v2 is 0. So corresponding to that Q matrix and 0 eigenvalue, we will get one eigenvector 1, 0, and another eigenvector, another vector v. Suppose v, I am relating that v comes from null space of q minus 0 into I square. That means null space of q square. So another vector v corresponding to eigenvalue 0, it is generalized generalized eigenvector of order 2 corresponding to eigenvalue 0. So it is not an eigenvector, it is generalized eigenvector. So in question it is asked to find the eigenspaces for 0, 1 and 2 pi I. So we will take that eigenvector from coming from Q, that Jordan block Q. I am renaming this. So from this Jordan block we have 0 eigenvalue, and corresponding to 0 eigenvalue we will get 1 eigenvector. Again corresponding to this Jordan block, corresponding to eigenvalue 2 pi I, we will get 1 eigenvector and another eigenvector, since that matrix P, which is 2 pi I 1 0 2 pi I. So if we take P minus 2 pi I and 2 pi I into identity, if we take square, we will get 0. So its minimal polynomial is given as x minus 2 pi I square. So it is a non-diagonalizable matrix, since its minimal polynomial cannot be written as a linear factor, distinct linear factor. So it's a non-diagonalizable matrix. So and it is nil, and P minus 2 pi I into identity is a nilpotent matrix of order 2. So corresponding to eigenvalue 2 pi I, we will get 1 eigenvector and another vector is generalized eigenvector of order 2 corresponding to eigenvalue 2 pi I. So and for this block we will get 1 eigenvector corresponding to eigenvalue 2 pi I, and for this block we will get 1 eigenvector corresponding to eigenvalue 2 pi I. So totally corresponding to eigenvalue 2 pi I, we will get 2 eigenvector, and corresponding to 0 we will get 2 eigenvector, and corresponding to 1 we will get 1 eigenvector. So in question it is given dimension, to find its dimension of eigenspace. Corresponding to 0 we will get 2 eigenvector, and corresponding to 1 we will get 1 eigenvector, and corresponding to pi I we will get 2 eigenvector. So option 4 is correct and option 3 is incorrect. So you will get 4.75 marks very easily from part C. So if you guys like this video, please don't forget to hit that like button and subscribe button. Thank you guys. Thank you for your time.